Welcome back. This is going to be the second video in section 7.4. This video is going to deal with the half angles. So if you'll go down to where we have the half angle identities, notice I've already filled them out for you. I will make a quick note that the plus minus symbol indicates that the sign is chosen on the basis of the function itself and on the consideration of where or what quadrant my half angle lies in. So you notice that 3 of these identities have the plus or minus, and then 2 of them do not. All right, so let's take a look at example A, and as I mentioned in the previous video, just have your identities handy so that you can easily refer back to them. It's difficult for me to show them at the same time. All right, so when we're looking at example 8 here, notice that we're asked to find the exact value of sine 22.5 using the half angle identity. So the first thing I did, I really didn't even do any math here. The first thing I did was I just wrote the identity straight off of what I got up here in my identities list. So I just simply wrote it. And I was asked to find the sine of 22.5. So I went ahead and plugged that in. And as soon as I see this, I can tell that the number 22.5 is going to be my half angle. If 22.5 is my half angle, then that means 45 degrees is going to be the measure of my whole angle. And this is going to help me because in my identity, this guy is what I'll call the half angle. This guy right here is going to be the whole angle. All right, so as long as we know what the half is, we can find what the whole is or vice versa. So let's go ahead then and we'll plug into our formula. This will be plus or minus the square root of 1 minus cosine 45 all over 2. Cosine 45, we know that 45 is smack dab in the middle of the first quadrant, so this is going to be the value of root 2 over 2. I personally like to get a common denominator up on top, and so what I will do on this is change this into a 2 over 2. Apparently I didn't do that right here. I went ahead and multiplied by the reciprocal though. And let's see, what does it look like that I did? Sorry about this. I distributed instead. So getting a common denominator is one option, or on this one, I distributed. So you have a 1/2 minus a root 2 over 4. And then I went and got a common denominator so that I have a 2 minus a root 2 all over 4, and all of that is inside my square root. And then what I did was I took the square root of the top and took the square root of the bottom separately. Now, it looks as though somehow in the middle of this, I lost my plus minus. So let's go back and talk about why I chose the positive value on this. And that's right over here. 22.5 is in quadrant 1. And so the sine of 22.5 is going to be positive because it's a quadrant 1 angle. So I chose, or it looks like early on, I chose the positive, and then I just didn't write it from there on out. All right, let's look at example number 9. So this says to find the exact value of tangent 75 using a specific half angle identity. So we're going to be using the tangent half angle is equal to the sine of the whole angle over 1 plus cosine of the whole angle. So the first thing that I need to know is, hey, if 75 is my half angle, then my whole angle is going to be 150. All right, so then what we'll do is we'll go ahead and write out our formula, only this time we'll use 150 for the whole angle. I already have the circle marked over here. And so the sine of that 150 degrees is going to be a 1/2. The cosine will be negative root 3 over 2. Looks like I'm getting a common denominator down on the bottom. So it's going to be a 1/2 divided by 2 minus root 3 all over 2. Then I can multiply by the reciprocal. That'll be nice because it'll cancel out my 2's. That's going to leave me with 1 over 2 minus root 3. It leaves you with this right here. The problem with this, the reason I had to go further was because there's a root in the bottom, and roots in the denominator, as we know, are not simplified. So I multiply by the conjugate over the conjugate. So that's what's in red. FOIL on top and on bottom, and that'll give me a 2 plus root 3 on top, a 4 minus 3 on bottom, which is just a 1. So I don't need that over 1 value. All right. This particular graphic I'm going to come back to. It's easier to explain it when I have an actual question that I'm looking at. So we'll come back to this particular example here in just a moment. All right, so on this one, let me move this here. On example number 10, we're given that sine of s is equal to this negative 2 root 10 over 7. And we're also told that my angle s is in the third quadrant. It's between pi and 3 pi over 2. So what you'll notice here over on the side is that I have a picture drawn already that gives me my opposite over my hypotenuse. I just need to find the missing side, which is going to be the x value. And once I do the Pythagorean theorem, I should get a 3. And since it's going to the left, it will be negative. All right, so the first thing that I'm going to do is I'm going to write my formula without looking at my picture. And so the sine half angle is going to equal this guy. Now's a good time to go ahead and talk about that graphic that I showed you just a moment ago and how to choose whether I want the positive version or the negative version. So notice here that my whole angle is in quadrant 3. My whole angle is in quadrant 3. Well, if my whole angle is in quadrant 3, where is my half angle? So let's come back up to this graphic. And I want you to think about all of the quadrant 3 values. You have anything from 180 all the way up to 270. And if you think about half of any of those, let's see, half of 180 is going to be 90. And half of 270 is going to be 135. So if I take half of any angle in this third quadrant, I'm going to land in the second quadrant, really in the first half of the second quadrant. So let's use that concept then down here. If my whole angle is in quadrant 3, then my half angle is going to be in quadrant 2. And that's what I have written here. My whole angle is in quadrant 3, therefore my half angle is in quadrant 2. I'm looking for the sine of my half angle, and sines in quadrant 2 are positive. So right off the bat, I'm going to choose the positive version for part A. Once I have the equation, the identity written, I can use my picture to plug and chug. All right, so we're going to choose the positive there. And I've got 1 minus a negative 3/7 because the cosine is negative 3/7 all over 2 over 1. I got a common denominator on top, and I multiplied by the reciprocal. So this is going to be 5 over 7 inside the square root. And when I rationalize the denominator, I'll get root 35 over 7. Now I'm also asked to find the cosine. Now I want to write my equation without looking at the picture. And then let's go ahead and choose whether it's positive or negative. We already decided that the half angle is going to be in quadrant 2. And cosines in quadrant 2 are negative. So here we're going to choose the negative. Let's go ahead and plug in. You see there that I did choose the negative, and I'm plugging in the cosine of my picture. All right, so again, getting a common denominator on that, this is going to become a 7 over a 7. And so 7 over 7 minus 3 over 7 becomes 4 over 7. Multiply by the reciprocal. Multiply your fractions, you're going to get 2/7 inside the square root, and then rationalize the denominator to get negative root 14 over 7. All right, the tangent is going to be very similar. I chose one that didn't use a plus or minus outside so that I didn't even have to worry about the plus or minus. So just choose one of those other two. And when we use our picture, cosine is going to become negative 3/7. Sine will become negative 2 root 10 over 7. I got a common denominator up on top. And that's going to turn into 10/7. You can see that underneath all my scribbling, 10/7. And then I went ahead and multiplied by the reciprocal on the bottom. I was able to cancel my 7s, and I was able to reduce my 10/2 to a 5/1. So that's going to leave a 5 on top and a root 10 on bottom. And then you can rationalize the denominator and reduce the outside fraction so that you get root 10/2. All right. And I'm just now catching a mistake that I made here. So let's go back and fix that really quickly. In fact, I'll do it in a different color so you can see the difference. When I multiplied by the reciprocal, I forgot my negative. And so this should have been negative, this should have been negative, and this should have been negative. And I'll tell you how I caught my mistake. My brain was thinking, hey, my half angle was in quadrant 2, and tangent values in quadrant 2 are supposed to be negative. I must have done something wrong. So use that all students take calculus concept that we've talked about earlier in the semester to make sure that your negatives are in the right spot. I did something really simple there, and it just caused an easy mistake, but it would have caused the wrong answer. All right, let's go ahead to example number 11. So for example number 11, we're asked to simplify again. This is a working backwards question. So all you need to do is go back to your identities and find an identity that matches this guy. And so that's going to be, where are they? That's going to be this one right here. So that's what I have written right now. Let's write the other side, which is the sine of the half angle. I'm not going to keep on scrolling because that gets a little tedious. So we'll plug that in then, sine of my angle 8x/2. So that makes it the half angle. Reduce your fraction and you'll get the sine of 4x. For this one, this is the half angle identity for tangent. So I'm going to plug in, I'm going to substitute tangent of my half angle. And here I cannot reduce 9/2, so I'm just going to leave it as is. All right, the last one is to verify an identity, and we're using half angles to do this. So on this one, I'm going to work on the left first, and I'll work until I get stuck, and then I'll move over to the right-hand side. So on this one, what I did was for the moment, I ignored the square, and I just looked at the tangent of the half angle, because the square just means it's the tangent of the half angle times the tangent of the half angle. So what I did was I used my half angle formula, and then I just squared it. And that's nice because this way my square root is going to go away and my pos neg is going to go away, because a positive squared is positive and a negative squared is positive. So both of those are going to go away, and it's just going to become 1 minus cosine over 1 plus cosine. All right, so now there are some things I could do, but I'm a little bit stuck. So I'll just go ahead and work on the other side. So on the other side, the first thing I did was I used reciprocal identities, and I turned my secants into 1 over cosines. Now I did 2 steps in one here. So that's the first thing I did, was I did 1 over cosines for the secants. But then the second thing I did was I went ahead and got a common denominator, and I did this in a different color. So I got a common denominator of cosine up on top, and I also got a common denominator of cosine down on bottom. So then the next step, I'm just going to combine all of these, and this will give me 1 plus cosine squared minus 2 cosine over cosine. That's the whole top. And then for the whole bottom, you have 1 minus cosine squared all over cosine. So now I'm just going to, so that was the adding and the subtracting of my fractions. Well, then I decided to divide my fractions, so I went ahead and multiplied by the reciprocal next. And that was nice because I was able to cancel then the cosine on top and the cosine on bottom. I noticed that this guy is a difference of 2 perfect squares, and when I saw that, I also saw that this guy can be factored as well. If you think of this as a 1 plus a squared minus 2a, this is a really nice factoring. And so the top factors to 1 minus cosine, 1 minus cosine, and the bottom factors to 1 plus cosine, 1 minus cosine. So I was able to cancel a pair of those. And once I canceled a pair of those, that ended up being the same place that I got stuck on the left-hand side.